Hello, everyone. Welcome to Generative AI Education Series. Do you ever wonder what exactly happens behind the scenes when you use tools like ChatGPT or Gemini? How is it possible that these tools can predict exact next word for the prompt that you provide? How is it possible that these tools can write code for you, can complete your sentences, can write essays for you, can summarize a large text for you, can answer precise answers to the question that you ask. These tools can do a lot of things for you, but it's important for us to understand how what happens behind the scenes, right? So that's the topic that we're going to cover today. I'm going to try to demystify generative AI for you. We'll cover different topics. At the end of this session, I feel that you'll have very good understanding of what is AI, what is machine learning, what is deep learning, where does generative AI fit in the entire artificial intelligence picture? Also, I'll give you a very good understanding of how large language models, also known as LLMs, work. How is it? How do they, create the map of words? How they are able to predict the exact next word for the prompt that you provide. I'll also take you through one demo where I can show you how easy it is for anybody to code simple generative AI applications. You don't even have to be a technical person. It's very easy for anybody to code generative AI applications. I'll walk you through that. I'll show you details of some of the architecture behind the scenes and also walk you through some of the key industry buzzwords so you don't feel like alien when people are talking about generative AI. So let's demystify generative AI. Let's get into details. So what I'm planning to cover is first, I'll give you very introduction to AI, very basics of what is machine learning, what is deep learning, what is generative AI, where does it fit in the big picture, and the basis of all this invention is called artificial neural network. It's important for everybody to understand how artificial neural networks actually work. So in the chapter one, I'll just give you basics of it because getting into details might lose interest to start with. So let me first give you basics of it. Then in chapter two, I will cover different types of artificial neural networks. Ideally, I should have covered the details of artificial neural networks before getting into types, but I fear that you might lose interest because artificial neural networks does need some patience to understand. So that's why I'm going to keep that chapter at the end. So first I'll cover basics, then I'll get into types. I'll reserve the details at the end if you still have interest. Then once we cover the types of artificial neural networks, then we'll cover what I feel is the most important chapter of this entire series, large language models. I think this is the chapter where you really want to pay very close attention to understand how large language models work. Large language models, also referred to as LLMs, I will explain you what are these LLMs, how do they represent the words, how they are able to calculate the exact next word for the prompt that you provide. I will take one example prompt. I'll walk you through step by step on for the prompt that you have provided, how did it calculate exactly the next word that mimics human creativity and imagination? How is it possible? Then once that is done, then once you have good understanding of how LLMs work, I'll show you the code and a demo application that showcases how easy it is for anybody. And when I say anybody, you don't have to be a technology person. Anybody can code very simple generative AI applications. Once you get good understanding of that, then you will know that hey, it's not that complex. It's fairly simple to understand. Now it was complex to build this entire ecosystem, but understanding it is not that complex. It's easy. So we'll go through that. Once that is done, then I will walk you through some of the key industry buzzwords, like words like what is multimodality, what is vector, what is embedding, what is RAG pipeline. When people talk about it, once you have good understanding of those words, then you won't feel like alien, right? When people are talking about it. So we'll cover that. And then the two more technical chapters that I have reserved at the end are for people who still want to get into deeper of artificial neural networks. I would recommend everybody to go through it, but I've reserved those chapters at the end. So chapter number 6 will cover neurons and neurotransmission, how it works in human brain. Artificial neural networks are inspired by how the human brain stores and processes the information. Artificial neural networks try to mimic that. So I will show you first how it works in human brain. Then I will show you side by side comparison of human neural network and artificial neural network, how they compare. How is it artificial neural network inspired by human brain? I'll walk you through that. I'll walk you through how neurons, what do exactly neurons do, what function they do, how the neural connectivity works, what are weights, what are parameters, what are biases, all that. And once that is done, then the last and most important chapter would be the transformers. Transformers is a type of artificial neural network that paved the way for this revolution called generative AI. So we'll talk about the architecture of transformers, how transformer architecture looks like. So that's the content that we are going to cover at overall. So let's start with first one. By the way, my camera is here, my screen is here, so you might see me, looking at screen a little bit from a different angle. So let's start with introduction to AI first. Um, you know, what is generative AI? Generative AI is advanced neural network algorithm that is designed to autonomously generate content that replicates human creativity, imagination, and discrimination. When I say that, it sounds very complex. Let me make it simple to understand. First, let's understand what is AI. AI is a machine or software intelligence which is unlike human or animal intelligence. It's different. AI by itself is not a thing. AI is a field of study, and it's a field of study that is focused on developing intelligent systems or software that mimic human imagination, creativity, and intelligence. That's what AI is. Within AI, there is a subfield called machine learning. Machine learning focuses on enabling machines to learn from data that we have and the experience of patterns in that data. So that's what machine learning focuses on, and I'll explain you at length in the following slides. But the most common algorithms, and there are a ton of algorithms out there for machine learning. The most common ones are like linear regression, random forest. These are the most basic algorithms that are used in machine learning. Now, within machine learning, there is another field called deep learning, and deep learning is a something that utilizes artificial neural networks. Now, the word deep means multiple layers in the network, multiple layers of neurons in the network. Nobody calls this a big network or a large network. It's always called deep network because there are multiple layers in it, and those multiple layers make it deep. The most common neural networks or artificial neural networks are CNNs, which are convolutional neural networks, or RNNs, which are recurrent neural networks, or even transformer is actually a artificial neural network. And within deep learning, then there is a field called generative AI. Generative AI is a type of artificial neural network that generates data similar to the data it was trained on. For example, if you train a artificial neural network on English language, then it understands and learns the statistical likelihood of one word following another in English language, allowing it to generate very coherent sentences and mimic the human imagination and creativity in English language. So that's what generative AI is. And the LLMs are probably the most common example of generative AI, artificial neural network, and we'll get into details of that. So that's where the generative AI fits in the big picture. Now, let's understand machine learning first. What is machine learning? Machine learning enables computers to learn from data or patterns that we have in our data. So if you, on this screen, you see there are two tracks. One is a training track and one is a actually task execution track. In training track, what you can do is you provide a label data to one machine learning algorithm. And machine learning algorithm could be random forest or linear regression. There are many algorithms. You can choose one that best fits your need, and you provide a label data to it. Combination of label data and machine learning algorithm creates something called train model. Then in the task execution, actual production task execution, what you provide is you provide real data to the train model, and this train model then what it can do, it actually can generate a prediction or make decision for you. That's what machine learning is. And the most simplistic example of machine learning that I can tell you is a email spam filter. Email spam filter is probably the most basic machine learning example you can think of. It email has, so what they did is that there was many years of email data companies like Gmail or Yahoo they took that data, they fed that data to machine learning algorithms, and they created trained model that now, based on this learning and patterns in the emails data of many decades, it learned to determine an email could be spam or could be a legitimate email. So when the real email data is fed into it, when email comes in, the trained model now can predict and decide whether that incoming email is a spam or not a spam. So that's the most basic example of machine learning. So now, what is deep learning? So deep learning is where algorithms learn the representation through hierarchy of multiple layers that I was talking about. So these are based on artificial neural networks that mimic the human brain, how the human brain learns and processes information. Now, again, just to show you difference between machine learning and deep learning. In machine learning, what you do is, let's say if you have a train model, not train model, let's say if you have data that is about cars or automobiles, and you use a say algorithm called classification algorithm, what you need to do is a human needs to a programmer or a human who understands how to extract features from this data. That human needs to label that data and extract specific features from that data, and then feed that data as well as those features to the algorithm, so algorithm can get trained. And the features could be for automobile data. Features could be, what is the engine type? Engine type could be a feature. Make of the car could be a feature. Year of manufacturing could be a feature. So these could be features that can be applied on that data. So you feed that data and those features to the algorithm, and then algorithm builds a model. And once when you provide the real data or image of a car, for example, then that model can tell whether that is a picture of a car or not a car. That's at high level machine learning. The problem here is though that all this is very simplified, oversimplified, and this whole the effectiveness of the model depends on how good this human creativity was. If this human did a really good job in designing those features, then model will be good. If this human did bad job in designing the feature, then model will not be that effective. So it requires good amount. It relies on human imagination. Number one, that's a problem. And second problem, it requires a significant time and design time and development time to build these models. Now, different from machine learning, what deep learning does, it actually combines these two steps into one step and automates the feature extraction and learning process. So what you do in deep learning, you provide the data, and then automatically the network will be able to extract the features it needs and be able to build the model. So recent is that these models are easy to adapt to any type of data. So you don't need to build different models for specific data. They can adapt to any type of data. They are very quick to learn. The only downside is that they need a huge amount of data. So that's the difference between machine learning and deep learning. Now, at high level, before I get into the details, one thing that I would like to get your attention on is artificial neural networks. As I said, artificial neural networks are basis of this entire revolution called generative AI, or a lot of things in AI, not just generative AI. Artificial neural networks are essentially computational models that are inspired by the way human brain processes and stores the information. They are designed to analyze complex data. They are designed to recognize patterns, and they are designed to make predictions and decisions for you. I will have a dedicated chapter on it later. At this moment, I'm just going to give you very basic information because that's what you need to know before you learn about generative AI. But I would recommend everybody to go through all the chapters and understand the details of artificial neural networks as well. On this slide, I'm going to give you very basics of it. Uh, at core, if you look at this diagram on the right side, there are multiple layers of neurons. This you see here. This is one layer that is called input layer, which has three neurons right now. These circles represent neurons, and the connections between these neurons are basically they are connections, and each connection has a weight assigned to it. The first layer where there are three neurons is called input layer. By the way, the diagram shows three neurons, but there are thousands of neurons in neural networks. Then the middle layers, which could be many layers. Here is showing only three, but there could be again depends on how many layers you want to design in your neural network. There could be many layers. Those layers are generally called hidden layers. And then the output layer is one or multiple neurons, but that's generally output. Neuron, what does neuron actually do? Neuron at core, it has a function. It so for example, let's take example of this neuron. This neuron is getting input from three different neurons, right? This neuron is receiving input from this neuron, also from this neuron, also from this neuron. So in this case, it's receiving input from three neurons. What it does, it actually adds up the information that it received from the previous layer of neurons. And then once it adds, then it performs a function like comparison with a threshold that it has already set. And then based on that comparison, it may decide to either fire or not fire. And what firing means that it executes something called activation function. And there are many activation functions, but activation function, one of the most common one is called sigmoid. There are different activation functions like ReLU and quotient. But just to tell you, this activation function basically performs some computation, and then output is passed on to the next neuron. That's the at simple. So at high level, neurons basically sums up the input that it received, compares, and performs some calculation if it decides to perform the calculation. The connection between two neurons is what I call in actually human neural network is called synapse. That's essentially in artificial neural network. It's essentially an input that received from the previous neuron, and each connection has a weight. So it's basically multiplication of input and weight. And then, as I said, the input layer is this one, which is what I've explained here. And in terms of functionality, the artificial neural networks learn by adjusting their internal weights, and these weights are at every connection to reduce the difference between their prediction and actual outcomes. So during the learning process, they learn these weights for different patterns in different situations. And when it comes to execute the task, they apply those weights on the task. And this learning process is done through algorithms like gradient descent. Gradient descent by itself is a different topic. I'll probably give you links to some of the videos that you can learn by yourself. But at high level, if you think of what is gradient descent is, now let's say if you're standing on top of a hill and you throw a ball, say a basketball, you throw it down the hill, that ball is going to follow a certain path to go down. um, Now, gradient descent is an algorithm that calculates the least resistant path for ball to go from top of the hill to the bottom. That's what at high level gradient descent is. But again, there is that topic by itself needs another chapter, and then in future probably I'll create a chapter for you to understand. So, so that's what artificial neural networks are. Now, again, this is very basic information. There is a detailed chapter about artificial neural network later on coming.